Although we can't feel it, our solar system is constantly being changed by galactic wind. The wind is composed of gases like hydrogen, helium, oxygen, and neon, which form a very wispy atmosphere between stars. This gas is called the interstellar medium. Like a bicycle traveling in a crosswind, the wind that the solar system feels is actually a combination of the solar system's movement relative to the galaxy and the movement of the interstellar medium itself. The solar wind pushes out against this galactic wind, forming a bubble called the heliosphere. The outer boundary is called the heliopause and is blown into a teardrop shape by the galactic wind. IBEX, or the Interstellar Boundary Explorer, is designed to study this region from Earth orbit and has now made the first direct measurements of hydrogen, oxygen, and neon from outside the solar system. Many instruments have seen the characteristic spectra of elements outside the solar system, but IBEX is actually detecting atoms from interstellar space that punch through the heliopause and strike the spacecraft. Only some of the atoms that make up the galactic wind can do this. Much of the galactic wind is made up of ions, which are atoms with charge due to missing electrons. The remaining atoms are neutral. They have the same number of electrons and protons. The ions are deflected by the magnetic field of the Sun, just like the magnetic field of the Earth deflects the solar wind, but the neutral atoms are unaffected and go straight through. The measurement of these atoms by IBEX has enabled scientists to get a better grasp on the environment around our solar system. The speed of the galactic wind registered around 52,000 miles per hour, which is about 12% slower than previously thought. At that speed, it still takes about 30 years for each atom to reach IBEX from the edge of the solar system. The IBEX measurements of heavy interstellar atoms, oxygen and neon, show a difference from the solar system and galaxy as a whole. This puzzle may mean that the Sun has moved out of the region where it formed, or that some of the oxygen has been captured by dust in interstellar space. These direct physical measurements of the universe right on the Sun's doorstep help us understand the history and future of our solar system and the galaxy. What scientists learn can help protect human spaceflight and teach us more about our home in the Milky Way.